In this video, we are going to be focusing on aquatic world with our latest exploration into fish survival mechanism. Oxygen is essential for all animals including fish, and understanding its role in water is crucial. In this video, we uncover the mysteries behind oxygen concentration, levels and their impact on fish health. Learn how even small changes in oxygen levels can affect aquatic ecosystem and discover the fascinating chemistry behind oxygen dissolution in water. Let's assume you're given this kind of problem which says fish, like all animals, need a supply of oxygen which they can obtain from oxygen dissolved in water. The minimum oxygen concentration level needed to support the fish, most fishes, is around 5 ppm, which is what parts per million weight per volume. How many moles of oxygen per liter of water does this correspond to? First thing, let's look at the meaning of ppm. When we say ppm, this simply stands for part per million. It is a unit of measurement used to express the concentration of one substance into another. Specifically, ppm indicates the numbers of parts by weight of a particular substance per million parts by weight of the mixture or solution. How can we solve this problem? First thing we need to do in order to solve this kind of problem is to convert ppm, weight per volume, to mass of the concentration in gram per liter. We said first thing we need to do is to convert what? We need the conversion at this point, that is ppm, weight per volume. We need to convert that into what? The mass concentration in what? Gram per liter. And the second thing we need to do is to convert the mass concentration of oxygen to moles. We need to convert the mass concentration of what? Oxygen into moles. You need to put this one down. Alright, let's start to solve this problem. In order for us to convert the ppm, weight per volume, to mass concentration, first thing we need to do, we know that 1 ppm weight per volume, 1 ppm in weight per volume is equivalent to what? 1 milligram per liter. And the molar mass of oxygen is approximately 332. Let's put this one down. Molar mass of oxygen is approximately 32. It's going to be 32 in grams per mole. Next thing we need to do is to calculate the mass concentration of oxygen. Let's put it down. Calculate the mass concentration of what? Oxygen. Mass concentration of oxygen in what? In gram per liter. Alright, let's start. Let's follow these steps. I think it's kind of a little bit tricky, but I show you, if you pay attention, it's not going to be hard. So the concentration of oxygen is simply going to be 5 ppm. We're going to multiply that by 1 milligram per liter. And we're going to divide everything by what? 1000 milligram per grams. In this case, grams will cancel out. We're going to be left with 5 ppm multiplied by 1 liter divided by 1000 grams. If you divide everything here, this is simply going to be 0.005 grams per liter, which is what? The concentration of oxygen. Let's put this one down. Second thing we need to do is to convert the mass concentration of oxygen into moles. So to convert grams to moles, we use the molar mass of oxygen. So numbers of moles of oxygen, you can set moles of oxygen is simply going to be the mass of oxygen. We're going to divide by the what? Molar mass of oxygen. We are given the mass of oxygen to be what? 0.005 grams divided by the molar mass, which we said the molar mass is 32 in what grams per mole. In this case, grams will cancel out. We are going to be left with 0.005. We are going to divide that by 32 in what? In moles. If you divide 0.005 by 32, this is simply going to be 1.56 1.5625 exponential negative 4. Therefore, the moles of oxygen is simply going to be 1.5625 exponential negative 4 in what? The unit is going to be moles per liter. So we can conclude at this point and say we have approximately 1.5625 exponential negative 4 moles of oxygen per liter of water, which correspond to what? 5 ppm, which is part per million, weight per volume. And this is it for this problem. Thank you for watching.